Hello juniors, today we're going to see electronic assignment number 42, which is about laws of logarithms. If you remember from exponents, we have seen some properties of exponents. We have also seen some properties of logarithms, but today we're going to see something that's called laws of logarithms, which is something that you have in the formula booklet. So normally this topic isn't quite difficult. You just need to really understand the concept of how logarithms work. So for today's objective, we have interpret and apply properties and laws of exponents and logarithms. So we're going to make some demonstrations, which you shouldn't know by heart, but it's good for you to know where these different laws come from. We're going to see 4 different laws of logarithms, and I wanted to show you where they come from. So we're going to start by doing the following. Consider the following exponential functions. And we're going to consider this too. X is equal to a to the power of m and y equals to a to the power of n. Okay? So same base, but different exponents. So if we consider this, we know that by definition, if you remember the first property of logarithm we saw in the last class, if we have a to the power of x equals b, we can rewrite this as this. Remember the rule. It's a to the power of this is equal to this. So a to the power of x is equal to b, which is exactly what we have written there. So using that same concept, we can rewrite these two expressions as m equals log base a of x. If you remember, a to the power of m is equal to x, which is this. And on the other hand, we have that n is equal to log base a of y. A to the power of n must be equal to y, which is exactly what we have written here. Okay, so from those two exponents, we can rewrite them in the logarithmic form. So you need to remember these two things because we're going to be using this throughout all of the 4 demonstrations of the laws of logarithms. So for the first demonstration, we could say that if we multiply x times y, this is the same as saying a to the power of m times a to the power of n, right? Because we have defined x and y as that. And if you remember from laws of exponents, properties of exponents, whenever we multiply two expressions with the same base, we can add the exponents, right? So this is the same as saying a to the power of m plus n. So I can say that x times y is a to the power of m plus n. But, no, not but. So we can rewrite this using the logarithmic expression. We could say that a to the power of m plus n is equal to x times y. So if we write it as a logarithm, it's logarithm of base a of x times y is equal to m plus n. Okay, so we just rewrote this. But we know that we defined m as log base a of x and n as log base a of y. This comes from here, right? So if I rewrite m and n using their equivalent expressions, this would be that log base a of x times y is equal to log base a of x times log base a of y. And this is exactly what the first law is about. If I have log of x plus log of y and I have the same base, in this case the base for both, remember the implicit base is 10, so they have the same base, then I can rewrite this as a single logarithm where the arguments are being multiplied, okay? This is the first law of logarithm. And here it says, notice that log of x times y is not the same as saying log of x times log of y. That's a mistake if you do it that way. And log of x divided by y is not the same as saying log of x divided by log of y. We're going to see how to find the the logarithm of an argument divided by another argument. Okay, we're going to see that it's actually the second law. Okay, so remember, this is the first law. Log of x plus log of y is log of x times y. Now we're going to go to the second law. From using our same definitions of x and y, if we divide x divided by y, this is the same as saying a times a to the power of m divided by a to the power of n. And if you remember from properties of exponents, when I have the same basis and I have them multiplied, I can subtract the exponents, right? So this is the same as saying a to the power of m minus n. So then, if I rewrite this expression using logarithms, I can say that a to the power of m minus n is equal to x divided by y. So I rewrite that, but using the logarithmic expression. And if you remember, once again, I'm going to copy this. M is log base a of x, and n is log base a of y. So I can rewrite this as log base a of x divided by y, and here we get the expression log base a of x minus log base a of y. So this is the second law of logarithm. If I have log of x minus log of y, I can join both into one single logarithm where the arguments are being divided, okay? That's exactly what we deduced from this demonstration. So once again, the bases must be the same in order to be able to join them into one single logarithm, okay? So the first logarithm is when we have an addition of two logarithms and we join them by multiplying the arguments. And whenever we have a subtraction between the logarithms, I can join them but dividing the arguments, okay? Now let's see the third law. So we're going to use our same definitions of x and y as always. We're going to say that x to the power of n, remember x is equal to a to the power of m, is the same as saying a to the power of m to the power of n, right? So whenever I have an exponent to another exponent, remember from properties of exponents, I can multiply both exponents. So this is the same as saying a to the power of m times n, okay? So if I rewrite this expression, once again using logarithms, and we're going to have that log base a of x to the power of n should be equal to the exponent, which is m times n, right? If you analyze it from this perspective, a to the power of m times m is equal to x to the power of n, which is exactly what we have right here. Okay, so we rewrite the exponential expression as a logarithmic expression. But if you remember from our initial definitions, m is equal to log base a of x. So I'm going to change this m over here. And this would be log base a of x to the power of n is equal to n in front times m, which is log base a of x. I wrote n in front on purpose, just for you to be able to see that this law, whenever you see this and you have an exponent in the argument, you can bring the exponent to the front of the logarithm, okay? And that's exactly what this law states. If we have log of x to the power of n, I can take the exponent down and rewrite it this way, n times log of x, okay? So that's what this third law is about. Whenever I have an exponent inside the argument, I can bring the exponent to the front of the logarithm. Okay, then we have this for you to think. It says, how can I express log base a of 1 over x using laws of logarithms? There are two ways in which one can express this using laws of logarithm. One is by using the second law, right? Which is that if I have a division between the arguments, I can separate the logarithm into two different logarithms, but subtracting the logarithm of the numerator minus the logarithm of the denominator. So I can say that log base a of 1 over x is the same as saying log base a of 1 minus log base a of x, right? And if you remember from properties of logarithms, whenever I have 1 as an argument, the logarithm is always 0, right? Here you have log base a of 1 is always equal to 0. Whenever the argument is 1, then the logarithm is equal to 0. So I can take this out, and we're just going to stay with this. Negative logarithm base a of x, and that will be the result, okay? So this is the the equivalent of this that we have over here. Another way of expressing log base a of 1 over x is by doing it this way. It says log base a of 1 over x. This is the same as saying log base a of x to the power of -1. Remember, I can take this up by changing the sign of the denominator, of the exponent, sorry. So if I change the sign of the exponent and then I apply the third law, which we just saw, I can take this -1 to the front and we're going to get the same result, negative log base a of x. So you see that it's just another way of evaluating the logarithm, but the result must be the same, okay? So it says that, yes, this was done using the third law, and this was done using the second law. Okay, so let's see some examples to see how the laws of logarithms work. Just in parentheses, all of these laws, and there's a fourth one which we're going to see in a while, but you can see that all of these laws are right here in the formula booklet. In topic 1 of the formula booklet, if you go scroll down, you're going to see exponents and logarithms. And these are the 4 laws. First law, second law, third law, and fourth law, which we're going to see in a while, okay? So you don't need to memorize all of these laws, but you'll see that with practice, you should be able to already remember these laws because they are quite easy. Okay, so let's go back and let's see the example. It says, express logarithm base 2 of 5 plus a half logarithm base 2 of 36 minus logarithm base 2 of 10 as a single logarithm. Okay, so the first thing I see is that all of the logarithms have the same base, right? Log base 2, log base 2, log base 2. So I will be able to join them as a single logarithm because of this reason, right? So one thing I can do first, if I want to join this, I need to make sure that I don't have any numbers in front of the logarithm. So one thing I can do is first take this and do the inverse of what we were told here in this law. If I have a number in front, I can take it up and write it as an exponent inside the argument, right? So that's the first thing I'm going to do. I'm going to take this as an exponent inside the argument. And that'll be it for the first step. So I'm going to write this as log 2 of 5 plus log base 2 of 36 to the power of 1/2, right? And this is minus logarithm base 2 of 10, okay? The next thing I see is that here we have an addition between this logarithm and this logarithm, and then I have a subtraction of, well, it's this logarithm minus this logarithm, but I can also consider it subtracting this logarithm, so it doesn't matter. So if I have an addition between two logarithms, I can join them by multiplying, right? If you remember the first law, if I have an addition between two logarithms, I can join them by multiplying the arguments. So that's exactly what I'm going to do. And one thing, before I join them, 36 to the power of 1/2, remember? I'm going to do it here. If you have 36 to the power of 1/2, this is the same as saying the square root of 36, right? And the square root of 36 is positive 6. So I can rewrite this as log base 2 of 5 plus log base 2 of 6 minus log base 2 of 10, okay? So now I can join these two by multiplying them, and since this is subtracting, I can divide this argument as well, okay? I can do that all in one single step. So this is the same as saying log base 2 of 5 times 6 divided by 10, right? We multiply these two arguments and we divide this argument. So this is the same as saying log base 2 of 30 divided by 10. And 30 divided by 10, that's 3. So the result of this would be log base 2 of 3. And this is the answer. We rewrote that whole expression as a single logarithm, which is what we're asked to do in this exercise. So log base 2 of 3 is our final answer. Okay, now let's see the next example. It says, given that a is log base 5 of x and b is log base 5 of y and c is log base 5 of z, then write log base 5 of the square root of x over y squared c cubed in terms of a, b, and c. Okay, so this becomes a little bit more interesting, right? What I will try to do is try to disarm this until I get all of these terms, which I can rewrite as a, b, and c, right? Which is what I'm being asked in this exercise. So that's what I'm going to do. I'm going to try to disarm all of this single logarithm into multiple logarithms. I'm going to do the opposite I did in this example. So the first thing I noticed is that there's a division between the inside the argument, right? So if there's a division, I can separate this using a subtraction between logarithms. So I can say that this is log base 5 of square root of x minus log base 5 of y squared c cubed, right? I subtract because there's a division here. Now, I see that inside here I have a multiplication between the arguments. So I can separate this single logarithm into two logarithms by adding the logarithm because there's a multiplication here. But I need to pay attention that this minus will be affecting both logarithms. So this is the same as saying log base 5 of square root of x minus parentheses log base 5 of y squared plus log base 5 of c cubed. Okay? And okay, so I can distribute the negative sign, and this would be log base 5 of square root of x minus log base 5 of y squared minus log base 5 of c cubed. Okay? Finally, what I can do is I'm going to rewrite this square root of x. I'm going to use the exponent form. This is x to the power of 1/2 because I will be now using the third law, right? Which says that if I have an argument to the power of something, I can take that exponent to the front, right? I can do the same thing here and same thing here. I can bring all of the exponents to the front. So that's the next step. I'm going to say this is equal to 1/2 times log base 5 of x minus 2 times log base 5 of y minus 3 times log base 5 of c, right? And that's it. Why? Because now we can replace their equivalent values. If you see, this is a, right? A is log base 5 of x. This is b, log base 5 of y. And this over here is c, which is log base 5 of z. So I can finally rewrite this expression in terms of a, b, and c by saying that this is equal to 1/2 times a minus 2 times b minus 2 times b minus 3 times c. And this would be the final result because we rewrote all of this logarithm in terms of a, b, and c. Okay, I hope this is getting clear for you guys. Okay, finally we're going to see the fourth law, which is known as change of base. As we did with the first three laws, I'm going to show you where this law comes from. But you don't need to know this by heart because you have the formula in the formula booklet. So we're going to do a supposition again. We're going to suppose that y is equal to a log base b of a, and you want to change to the log base c. Okay, so we want to change base because that's what the fourth law is about. So I want to change, instead of being base b, I want it to be base c. Okay, so how do I do that? If I say, if y is equal to log base b of a, then this is the same as saying that a is equal to b to the power of y, right? b to the power of y is equal to a. That's exactly what we have written here. So if a is equal to b to the power of y, then if I apply logarithm to both of this, to both sides of this equation, I could say that log base c of a is equal to log base c of b to the power of y. The only thing that I did was apply log base c to both sides. So I'm going to write that here. Apply log base c to both sides. Okay, so if I did that, then I can say that log base c of a is the same as saying y times log base c of b, right? I took the exponent down to the front and rewrite it as y times log base c of b. Then, if I say this, if I solve for y, if I leave the y alone, then I can take this, all of this term, dividing to the other side, which is exactly what I have written here. Y is equal to log base c of a divided by log base c of b. But if you remember, from the beginning, I have defined y as log base b of a. So finally, I have this expression, log base b of a is equal to log base c of a divided by log base c of b. And this is exactly the change of base formula, okay? Here it says change of base formula. If I have log base b of a, I can change it to a different base by doing this, log base c of the argument divided by log base c of the previous base I had, okay? Here it says this formula is useful as most calculators only give logs to base 10 or e. In our particular case, we can define different bases, so this thing is not an issue for us. But it's important for you to know how change of base works, especially for paper 1 exercises where you're not allowed to use calculator. Okay, so let's see some examples to see how change of base applies. It says, evaluate log base 100 of 1,000 by changing to base 10. If I apply the formula, we're going to say that log base 100 of 1,000 is, if I want to change to base 10, which is what I'm being asked, then this would be log base 10, this would be log base 10. So I'm going to write as log base 10. I don't need to write that because the implicit base is 10. So log of 1,000, which is the argument, divided by log of 100, which is the previous base we had. And if you know the concept of logarithm, 10 to what power gives me 1,000, and that's 3. And then 10 to what power gives me 100, and that's 2. So the result is 3 over 2, okay? So that's how we apply change of base formula. Now let's see this example to finish. It says log base x of 3 is equal to p, and log base x of 6 is equal to q. Find log base 3 of 6 in terms of p and q. Okay, so if I want to find this, I need to write this as log base 3 of 6, okay? Now, what pieces of information do I have in this exercise? I have that log base x of 3 is equal to p, and that log base x of 6 is equal to q. So I see that I have here a base, and here I have another different base. So the first thing I need to think about doing is change of base, right? So if I change this expression to base x, then I will apply the formula and say that this is log base x of the argument divided by log base x of the previous base, which is 3, right? And I have the values for these two expressions. Log base x of 6 is q, and log base x of 3 is p, right? So the result of this would be equal to q divided by p. Q over p. And this is the result for this exercise, okay? So I would say that log base 3 of 6 is q divided by p. And this is the result in terms of q and p of P and Q as I was asked to find in the exercise. Okay, so I hope this was clear. The 4 laws of logarithms, which are all, once again, in the formula booklet. Here you have change of base, multiplication of logarithms, which I can separate into an addition, division of logarithms, which I can separate into a subtraction, then the exponent rule, which says that if I have an exponent here, I can take it to the front and rewrite it this way, and finally, change of base, which is the last thing we saw today. So I hope this was clear enough. If not, please let me know. We're going to clear it up in future live sessions. See you.